Dear students, now let me solve this problem. This problem is based on the constant equation that I have discussed earlier. So here we have to find out the relation between the masses m1, m2 and m3. Okay. So to do this, what we have to do first? We have to first choose a reference line, and as usual, I like to choose the reference line over here. So this is our reference line, and then I have to locate the masses with respect to this reference line. That is the position of each and every masses with respect to this reference line. So let me take the position of m1 with respect to this mass is x1. With respect to the reference line is x1, and position of m2 is x2. So if we talk about the position of m2 from this reference line, then this will be our x2, and the position of m3 with respect to the reference line is x3. Now I have to think about one thing also, that this pulley is also moving downwards when this mass will be moving upwards. So we have to locate this pulley also. So let me, this is x4. Okay, so the position of this pulley is x4. Now we have to find out the relation between m1, m2 and m3. But in the expression of the constant equation, there will be x4 also. So we have to eliminate this x4. Now let me first write down the constant equation. Here there is two strings. One string is this and another string is this. But as there are two separate strings, the length of each individual string will be same. So if we talk about the first string, that is this string, what will be the total length? This side the length is x1 and this side the length is x4. So for the first string, x1 plus x4 equals to constant. Okay, so we will get the first equation, that is x1 plus x4 is equals to constant. Now if we take the derivative of this x1 and x4 with respect to t, we will get v1 plus v4 equals to 0. And if we take again derivative with respect to t, then we will get a1 plus a4 equals to 0, which implies that a1 equals to minus 4. So this is our relation 1. Okay. Now for the second string, we have to find this length and this length. Now what will be this length? And this length is nothing but x2 minus x4. If we talk about this x2 with respect to the reference line, and then if we subtract this x4, we will get this length. Okay, so this length is nothing but x2 minus x4. So this will be x2 minus x4 plus this length. This length is what? From this reference line, this is x3, and if we subtract x4, then x3 minus x4 we will get this length. So this will be x3 minus x4. So plus x3 minus x4, and this x2 minus x4 and this x3 minus x4 totally give this total length. Okay, and this total length of this string will again constant, so it will be constant. Now we will now if we take the derivative twice like this, we will get the direct relation of the acceleration. So it will be a2 minus a4 plus a3 minus a4 equals to 0, because the derivative of constant is 0. So it will be a2 plus a3 equals to 2a4. Now if we substitute this a4 by minus a1, then we will get the relation between a2, a3 and a1, because we have to find the relation between m1, m2 and m3. So we have to eliminate x4 or a4. Okay, so now if we substitute this value, it will be a2 plus a3 equals to 2 into minus a1, that is minus 2a1. So the final relation will be a2 plus a3 plus 2a1 equals to 0. This will be the relation between the acceleration of the masses m1, m2 and m3. Now the problem, if the problem is set like this, now if we are asked to find the tension in the string and acceleration of each block, then we will use the equation of motion from Newton's law, and then we will use this constant equation, which will totally give the result of the problem. Okay, so in the upcoming problems or in the upcoming lectures, I will discuss that types of problem, that how we can determine the tension in the string as well as the acceleration of each block. This is just the relation between the acceleration, and this is the first step to do a problem like this. So I have just discussed the constant equation only and how we can find the relation between the acceleration. But the rest of the problem, when we are asked to find the tension in the string also and each and the individual acceleration, then in that case I will discuss later on. Okay, thank you.